When you hear the phrase artificial consciousness, your mind probably jumps straight to sci-fi, right? Robots with feelings, all that stuff. But what if the real goal isn't to create a machine that feels, but one that functions in a really specific, measurable way? Today, we're going to dive into the engineering reality of it all, moving past the philosophical mysteries to see how artificial consciousness is actually being built, one function at a time.
All right, to really get what's happening in AI today, we've got to go back. We have to start with this one philosophical question that, believe it or not, kind of put the brakes on the whole field for decades.
So back in 1974, a philosopher named Thomas Nagel asks this question that sounds super simple on the surface. He wasn't asking about the physics of echolocation, no. He was asking about the subjective, first-person experience. What does the world actually feel like from inside a bat's mind? This gets right to the core of what we usually mean by consciousness.
And that question, that simple question, perfectly captures what we now call the hard problem. How does a bunch of physical stuff, neurons in a brain or circuits in a computer, give rise to a subjective feeling? For engineers, this is basically a brick wall. You can't measure a feeling, you can't write code for an inner experience, and for a long, long time, this just stopped progress in its tracks.
So if that's a dead end, how do we get past it? Well, it turns out the solution is to make a really critical distinction. We've been using one word, consciousness, for two totally different things, and splitting them apart changes everything. Okay, so look at this split. It's everything. On one side, you've got what's called phenomenal consciousness. That's the bat's inner world, the subjective feeling, the hard problem we can't really solve. But on the other side, we have access consciousness. And this isn't about feeling at all, it's about function. It's about having information that's ready to be used for reasoning, for planning, for explaining yourself. And that is an engineering problem. That's something we can actually build. Right, so here's the bottom line. Access consciousness is all about making information usable. Think of it like this. Your computer can tell you it has an error. It has access to its own internal state, and it can report on it. But is it feeling sad about the error? No way. It's just accessing and reporting data. That's the whole game right there. And the philosopher Ned Block actually broke this down into three key hallmarks. First, inferential promiscuity, which is just a super fancy way of saying that information isn't stuck in one box. It can be pulled out and used for all sorts of different jobs. Second, it helps the system take rational action to achieve its goals. And third, it can be put into language. The system can actually tell you what it knows or why it did something. And this is where things get really cool for engineers, because once you can define something like this, you can start to design it. So what does the blueprint for an AI with access consciousness actually look like? Okay, here's the blueprint. It's basically a loop, a cognitive cycle. The system uses selective attention to filter all the noise, holds the important stuff in working memory, and then, this is key, it builds a model of its own internal state. That's the introspection part. From there, it reasons, makes a decision, monitors how it went, and then finally, it can report on why it did what it did. And notice what's missing. There's no feeling module. It's all function. And what do you get when you build a system like this? You get something that is huge right now, explainable AI, or XAI for short. A system that doesn't just spit out an answer, but can actually walk you through the why and the how of its own thinking process. And I want to be clear, this isn't just some drawing on a whiteboard. This kind of functional consciousness is already out there, in the wild. I mean, check this out. We're talking more than 20 major cognitive architectures. These are like the foundational blueprints for building smart systems, things like SAR or ACTR if you know the names. And they're all built around these core ideas of access and self-monitoring. This isn't some fringe idea. It's a huge and growing field. And this is where the rubber really meets the road. That blueprint we looked at, it's being put to work everywhere. Think about healthcare. AIs that help doctors with diagnostics, catching things a human might miss. Or in education, creating custom tutoring systems that adapt to how you learn. This is real technology with real, tangible benefits. But, and this is a really important but, let's be crystal clear about one thing. These systems are not sentient. They don't feel anything. They are incredibly complex tools, for sure, but they're just executing operations based on how they were designed. The line between a system that can functionally report its state and one that actually feels it, that line is still absolute.
Okay, to really hammer this point home, let's step back and look at a great analogy from the history of engineering. It shows exactly why just copying nature isn't always the best way to get things done. For ages, people trying to fly built these things called ornithopters, machines with flapping wings trying to perfectly copy birds. And guess what? Every single one of them failed. We only cracked flight when we stopped trying to be a bird and instead focused on the function of flight, generating lift. And we did it with propellers and turbines. The goal was never to build a mechanical bird, it was to fly. And this brings us full circle, right back to our bat. Bats use echolocation, ultrasound, to navigate. It's amazing. But when engineers needed a system to do the same thing, did they try to recreate the bat's brain? Nope. They invented radar, which uses microwaves. Radar doesn't care what a bat feels. It just achieves the same function, often in a way that's even more powerful for our needs. And this quote just nails it. The goal was not to recreate what the bat feels. The goal was to build a system that works. That's the engineering mindset in a nutshell. You know, for centuries, our stories have been filled with these ideas of artificial beings, from the ancient golem to HAL 9000. And all that cultural baggage, all that fear and fascination, has really distorted the conversation around AI. It's made consciousness this big, scary, loaded word, when the technical reality is so much more practical. So what this all means is we have to reframe that original question. The real engineering goal isn't to figure out what it's like to be a bat. It's to understand what being a bat functionally entails. What are the actual mechanisms it uses for navigation, for filtering out noise, for adapting its behavior? And that leaves us with a final, really important thought. Maybe, just maybe, for the future of AI, the question we should be asking isn't the big philosophical one, can an AI feel? Instead, maybe the most important question is the practical, engineering one, can an AI explain itself? Because a system that can do that isn't just more useful, it's more transparent, it's more trustworthy, and in the world we're building, a world that relies more and more on AI, well, that might just be the most important goal of all.